number one and nothing less.
Alright, look at what we have here. So this is just a summary of what I just explained. So fundamental quantities and units. The quantity, the units, unit abbreviation, length, unit is meter, small letter m, time, unit is second, small letter s, electric current, ampere, that's capital letter A, temperature, Kelvin, that's capital letter K, amount of substance, mole, and that's what MOL. So we have other ones you can do your research. Now derived quantities and units, these ones are even numerous. Quantities derivation unit, area, that is abbreviated as A, is the length times breadth meter square, volume length times breadth times height meter cube, density, rho, mass over volume, kilogram per meter cube, or whether I write this or in this form, it means same thing. Velocity, displacement over time, which is meter per second, or this form. Acceleration, change in velocity over time, which is meter per second square, or this. Energy or what, that's first times that, which is Newton meter or what, joule. So we have this be like an exercise. So let's see what we can do about this. Now imagine you have this. Now one of the things you need to note as science students, of which I've seen is one of the challenges of students. Student tends not to be very, very creative as regards how and the nature of how questions can come in examination. Everybody will read, oh, this one, what's fundamental quantity is crammed, they just know it by table. But imagine that we have this example. Many students will say that they've not taught me, and yet it's false. It's just a way, instead of stating that what's fundamental quantity an example, I will just bring this. So look at the column, type of quantity, name of quantity, unit, abbreviation, then derivation. Now for the first, all these are in blank, but the unit abbreviation is meter squared. So go unit abbreviation for the fact that, look at what's the unit, meter squared, then trace it. Which one has meter squared? That's area. So the name of the quantity is area. Then type of quantity. What's the type of quantity? Is derived. Then derivation. What's the derivation of area? That is length. Length times breadth. Oh, this and time. Sorry, it's supposed to be seconds. Yes, it's what times. So now, for this. Now this is fundamental, and there's another thing that was given here, small letter s. So check on that fundamental, which one has s? That's time. So name of the quantity is time. And note, derivation, fundamental quantities are not derived. So they're not derived from anything, so that's nil. There are some questions that your teacher will ask you to test you whether you really understand, because some people might still formulate, they will believe that provided they've asked that they must put an answer. No, that's nil. Now for the derivation is displacement over time, and for it to have derivation, that means it's a derived quantity. Displacement over time, that's velocity. So name is velocity. Type of quantity is derived, and the unit abbreviation, that's meter per second. So anyone you choose to use meter per second. Anyway. Then this length, name of quantity is length. Now length is what? Is a fundamental quantity. Fundamental quantity. Then unit abbreviation of length, that's meter, and derivation. Fundamental quantity has no derivation, so that's nil. Then this one is open. It's an open check. Then you can choose anyone. So derived quantity. So think, which derived quantity can we use? Okay, which one will I use? Let me use force. So derived quantity, force is a derived quantity, and unit abbreviation, force is Newton, which is also either it's a Newton, or you can also write kilogram meter per second squared. And the derivation, force is what? Mass times acceleration. That's where we get this from. But this Newton is given to honor our great scientist Sir Isaac Newton, because he was the one that brought our derivation of force. So that's why this. But as regards the derivation, that's where this one comes. Mass, kilogram, acceleration, meter per second squared. Then fundamental. Then anyone, let's choose which one we choose. Let's choose temperature. So name of quantity, temperature. Unit abbreviation, that's Kelvin. Please, not degrees Celsius. Kelvin. Derivation is nil. It's a fundamental quantity. So this is just the summary of your fundamental quantity and your derived quantity. So let's proceed. Now, regarding measurement, these quantities that we have, there are ways we measure them. So, length, we have things we use in measuring length. Mass, things we use in measuring mass, and likewise time. So, for your length, you can use meter rule. It's an example of a meter rule. The one used in the laboratory, the meter rule. Then we have our calipers, linear calipers, micrometer, screw gauges. Now, one of the things you need to understand is what they call parallax error. Anything that has graduation, you must avoid parallax error. What does parallax error mean? Whenever you want to read a measurement, you put your eyes directly above it. You don't stand at an angle and you be reading. No, put your eyes up directly above it and you read. That's how you avoid parallax error. So you don't stand, stay at an angle and you be reading. So you don't do that. So then your calipers is just a device that has two jaws. When you're able to use it, you can maybe use it to measure a particular, maybe the diameter of a particular solid. Then you now take the jaw to a meter rule and you get the extent to which it has been measured. Now, as regards volume, there are many ways to deal with volume because length and volume is derived from length. So there are many devices measuring volume. Now, if you check, this is a volumetric flask. That is 500 centimeter cube, so the mark is here. So immediately you fill it with water to this grade, that's 500 cm cube. Now you have your beaker here. It's in sizes. This is 250 cm cube. You have your conical flask. It's also in sizes. Now you have your pipette. 25 cm cube pipette. So immediately you suck the liquid to this mark here. That's 25 cm cube. You also have your burette. Yeah, burette is 50 cm cube burette that you used to measure all this for measuring volume. Now, likewise, as regards to your mass, for mass, you have your digital weighing balance, as you can see. Now, this has a particular button where you can zero it. Whatever you put on it. Normally, if you want to measure a particular substance, maybe a powder. You have to put the scale there. You now first you know the weight of the container before putting it, but now this you can just zero it. Now whatever you put inside now is exactly the weight of that thing you are measuring. So then our balances have been upgraded. So here is another one depending on the capacity. Here is another one too. Now the one that can measure weight, all the ones that I just used measure mass. But the one that can measure weight is what we refer to is our spring balance using the principle of elasticity. When you apply it, it reads. You can see it is even calibrated both in newtons and in grams. So you can measure both the mass and also the weight. So this can be used to measure this. The spring balance can be used to measure weight. So one of the devices used in measuring length, especially as regarding the internal and external diameter of a particular tube. Imagine I want to know the diameter here and the internal one too. So vernier caliper is actually used. Now, their calculation as regarding the vernier caliper is very common in basic question in JAM and WIAT. So let's see this. This is a particular vernier caliper. Now it has two types of scale. We have the main scale. This is the main scale. And this is the vernier scale. Now let me make you understand something so that you don't just get confused as regards what we are doing. When you have a meter rule, reading accuracy is 0.1. This is what it means. For a meter rule, if here is 0, you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, which is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, which is 2. So for every meter reading accuracy is 0.1. What does it mean? That is, you can read in 0.1, you know exactly what it is, 0.1, 0.2, 0.3 till 1, 1.1, 1.1, 1.3. But anything that makes it come to this middle, you have to use your own discretion. Whether 1.1, you say 1.24, some of them are 1.25. So there, the meter rule cannot be accurate. So that's the advantage of the vernier caliper. So this, if you look at for this kind of caliber, now let me now show you how you read. First and foremost, you go to the main scale. Look at it. What we have here, we have 2. So this is 2.1, we have 2.2. So now, for our meter rule, this one, instead of us using our discretion, so we have a vernier scale that will tell us what this place is reading. So from the main scale now, we have 2.2 already. 2.2. Then plus, automatically you know that the vernier scale is actually reading what is here, so it will be 0 point, because it's actually telling us 2 point what? 2.2 what? Is it 2.24? Is it 2.25? 2.223? So it's actually reading 0.0. That is the number here. That's actually what the vernier scale is reading. So from here, then the principle is that you now check the graduation on the main scale and the vernier scale. Where do you have the two coinciding? That is, where do they meet? If you look at this one, it's not touching anyone. It's not meeting. It's not meeting. It's not meeting. Where it meets is these. You can see. So you now read. This is 1, 2, 3, 4, 5, 6, 7, 8. This 7, 8, 8. So this is 8. So in a nutshell, the reading here is 2.2. That is 2.2 what? 2.28 centimeter. That's the reading. This is how you get it. So likewise, so this is reading on the main scale 2. So 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, 3. So we're already at 2.2. Then the vernier scale now, now look at the graduation that coincides with the main scale. So coming here to look at it. This is 4, this is 4.5, 4.6, 4.7, 4.8. So on the main scale we have 4.8 watts. That's 4.8 plus 0.0. 4.8 watt. Then you don't check. Where does it coincide? If you check, it coincides at this level. 1, 2, 3, 4. So that is 4.84. So that the answer is 4.84 centimeter. This is how to read. 4.5, 4.6, 4.7, 4.8 what? 8.1, 8.2, 8.3, then 8.4. It's the fourth one that coincides. So the reading is just 4.84. Now, if we are going to go with this. So for this, similarly, without wasting any of our time to be adding, this is just simply speaking. Come and check. Which one coincides? This one did not touch, this one didn't, this one didn't, it did not. But this one, this is, look at it, there's an intersection of the two. So, and it is at this 5, this 6, 7, 8, 9, this is at 9. So for you to read simply, it's just, this is 6 from the main scale, 6.1, 6.2, so 6.2, 2 what? 2.9 centimeter. So that's your reading. And if you want to follow this, so it is just 6.2 plus 0.09. That's 6.2 centimeter. I hope we are clear with this. I believe with what we have done, if you see any of the reading of vernier caliper from your jam or it should not be difficult for you. Now let's now proceed to dimensions of physical quantities. Now before coming here, let me quickly state this. In physics, there's a difference between mass and weight. In chemistry, both terminologies can be used interchangeably without meaning any difference. So the mass of something, the weight of something, but in physics is different. Mass is just the quantity of stuff or material substance in a body, while weight is the force or pull with which the earth attracts a body towards the center of the earth. What does it just mean? Look at, immediately you leave, it comes down. So it is the weight that is making it to what? To come down. So weight always acts downward. So this one thing that should be in your memory anytime, any day. When they say what is the direction of the weight, weight is always downward. That chair you are sitting down on, if something should happen to that chair, you must go down. You just have to go down by virtue of your weight. Weight always acts downward. So I don't want to go to the concept of scalar and vector because I've not gotten there, so I'm not introducing it. So just to get it, mass is the quantity of material substance, or weight is that force of pull with which the earth attracts everybody towards its center. So now, dimension of physical quantity. Now, when we are dealing with this, is a way to what? Express all physical quantities in terms of the 3 fundamental quantities. And remember, what are the physical fundamental quantities? Your length, mass, and time. And your length in dimension is written as capital letter L in bracket. Your mass is written as capital letter M in bracket, and your time is written as capital letter T in bracket. These are the 3. There are other other fundamental quantities that are also used, like luminous intensity, yes. But these are the three main ones at least to your basic level of secondary school. So let us check. If they ask you to find the dimension of volume. So first and foremost, I will teach you two ways, because especially in jam you don't have time. But I will teach you the long approach and the short approach, so that in the nature of exam that you are, you know how to easily survive. Like I always tell my students that time is your greatest enemy in an examination hall. So you must learn how to beat time. So when it's an objective, you don't need to be solving all the rigorous solving. Just use some short approach of which I'm going to show you. So find the dimension of volume. So first and foremost, you go back. What is the derivative? How do you derive volume? Your volume is what? Length times breadth times height. That's what. Now, one of the things I need you to know is that the position of an object determines the name we are going to call its dimension. Look at when something is like this, we say what? This carton is 5 meters long. But immediately like what we will say, this carton is 5 meters high. But both the one we are saying long and the high, they are still distances. So length, breadth, or height are just what? Different dimensions of a particular body based on its position, and for us to know the difference. So the one that is flat, that is kind of lengthy, we call it length. The one that is flat, that is short, we call it breadth. Then the one that is standing, we call it what? Height. But all of them are still distant. So immediately you've written the parameter in terms of height is gotten, length times breadth times height, then you now take it back. On this, under which tree is this talking about? If you check, length is talking about length, breadth is still under length, and height too is still dealing with what? Length. Then L times L times L, so that's what? L raised to 3. So the dimension of volume is just what? Length raised to 3. It's just it. Now, the short approach I told you about is just to use your unit. Just use your unit. Now, what is the unit? Unit of volume. Unit of volume is what? Meter cube. And meter is the unit of which of these dimensions? That is length. So that is L. That's it. So you can either use this from the derivation, or you use the concept of the unit. Now let's proceed to another one too. Density. Density is what? Mass. So you need to memorize all those derivations I stated for you at the earlier and at the start of this video, this class. So mass over volume. Then if you look at mass, it's on its own, is under this, which is M. But volume, it is derived as what? Length times breadth times height. Then which is M over length is length, breadth is length, height is also length, which is M into L cube. And from here, from our indices, bringing this will take it upward, it will now be M, and this L will now raise to a minus 3. So the dimension of density, is ML raised to a minus 3, or using the unit like I said. So unit of density is kilogram per meter cube. Look at it. And kilogram is the unit of which fundamental quantity? Is mass. M is the unit of which fundamental quantity? Is length. L then minus 3. So I'm giving you this approach. If you are in a theoretical exam where they say you use this, but if you are in a particular exam where it is objective, just pick the unit and you just finish it up in no time. And I believe nobody will penalize you for that. So let's go to force. Force is what? Mass times acceleration. Mass and acceleration. Then mass is what? M. Now acceleration is actually a compound. Acceleration is what? Change in velocity change. over time, and it should be equal to mass times velocity change. Velocity itself again is what? Displacement. Velocity itself is what? Displacement over time on its own, then over that first time. And by our principle of mathematics, the time will come down to multiply itself, will not be displacement over time times time. Yes. Now if you check, now taking it back to our fundamental quantity, displacement, when they say something is displaced, this pen is here, I kick it and it's displaced to here, it has covered length, so displacement is still length. So displacement is length over time, that's t, times another t. Then this is now m times L over t squared. You know, indices is now m. Combining these two, it will now be times L, then t raised to the power minus 2. Then combining this in one bracket, so your force will be equals to m L t raised to the power minus 2. So this is it. Is it? Or using the units. Please, you have to be very versatile. So units of force. Yes, we all know that is Newton. That's why you're now break you and from what I give you, break Newton down. Newton is what? Kilogram meter per second squared. That's from using this now. Kilogram is the unit of mass, meter is the unit of length, and seconds is the unit of time raised to the power minus 2. You can see that using these units, you just get your answer directly. This is appropriate for objective examination. So please use this. I can't solve all for you, but with the basics I've given you now, go into other ones and learn what you call dimensioning. Try dimensioning for work, for energy, and for different other physical units. So in summary, for this video I just released, we talked about all our fundamental quantities, derived quantities, their units, the derivation, length, mass and time, how they are measured, calculation involving their measurements regarding vernier calipers. Then we'll talk about dimensions of physical quantities. I showed you how you can get their dimensions regarding the long theoretical processes, and how you can just get it using their units for mainly for objective exams. So from what we have done today, if there's anything you don't understand, you can leave your question in the comment section. Like I always say, not because I want this video to go viral, but don't deprive someone that needs this knowledge. You knew how you find it challenging, you understand all this in physics. Don't allow the generation after you to suffer what you suffer. So share this video to that person in secondary school, or even outside secondary school, because you might still need this in his university. Thank you very much. God bless you.